बिहानको 10 बज्यो। यो समय घरमै बसेर सुनेर पढ्न मिल्ने कार्यक्रम रेडियो स्कुलको हो। नमस्कार हाम्रा प्रिय विद्यार्थी भाइ बहिनीहरू, तपाईहरू सबैजनालाई कार्यक्रम रेडियो स्कुलमा हामी हार्दिक स्वागत गर्दछौं। कार्यक्रम रेडियो स्कुल लकडाउनको बेला विद्यालय बन्द हुँदा शिक्षण सिकाइ क्रियाकलापबाट विद्यार्थी भाइ बहिनीहरू वञ्चित हुनु नपरोस् भनेर तयार पारिएको सिकाइ सहजीकरण कार्यक्रम हो। यो कार्यक्रम मेचीनगर नगरपालिकाको सहयोग एवं शिक्षक महासंघ प्याप्सन तथा एनप्याप्सन मेचीनगरको समन्वयमा उत्पादन गरिएको हो। भाइ बहिनीहरूलाई थाहै छ, हामी आइतबारदेखि शुक्रबारसम्म कक्षा 5 देखि 10 सम्मका भाइ बहिनीहरूका निमित्त रेडियो कक्षा प्रसारण गर्छौं। आज बुधबार विज्ञानबार, आज सबै तहहरूमा अंग्रेजी माध्यमको विज्ञान विषयको कक्षा सञ्चालन हुनेछ। 10 बजेदेखि 10:30 बजेसम्म कक्षा 5 र 6 का विद्यार्थी भाइ बहिनीहरूका लागि कक्षा सञ्चालन हुनेछ भने 10:30 बजेदेखि 11 बजेसम्म कक्षा 7 र 8 का विद्यार्थी भाइ बहिनीहरूका लागि कक्षा सञ्चालन हुँदा 11 बजेदेखि 11:30 बजेसम्म कक्षा 9 र 10 का विद्यार्थी भाइ बहिनीहरूका लागि कक्षा सञ्चालन हुनेछ। रेडियो साथी 98.6 मेगाहर्ज, रेडियो साथीको फेसबुक टाइमलाइन तथा अनलाइन radiosathi.com लगइन गरेर पनि कार्यक्रम सुन्न सक्नुहुनेछ। अबको पालोमा कक्षा 5 र 6 का विद्यार्थी भाइ बहिनीहरूका लागि विषय विज्ञ शिक्षकज्यूहरूबाट कक्षा सञ्चालन हुँदैछ। त्यसैले कापी कलम लिएर रेडियो सुन्दै टिपोट गर्दै पढौं है त।
Hello and good morning, my dear class 5 students. My name is Kiran Limbu. I am your science teacher and I am from Thesis English Secondary School, Badakhal. I hope you are ready with your copy and pen to study. Okay, let's start. Previously, we learnt about invertebrates, vertebrates and shell. Invertebrates are those organisms which do not have backbone in their body. For example, amoeba, cockroach, leech, earthworm, etc. Vertebrates are those animals which have backbone in their body. For example, bat, elephant, human being, etc. Shell is the fundamental, structural and functional unit of life. Today we will discuss about the life cycle of the butterfly. It is the 4th unit of class 5 science. Here in the life cycle of the butterfly we will know what the life cycle is and the different stages of life cycle of the butterfly. Here let us know about the butterfly. You already may have seen the butterfly. Butterfly is a beautiful flying invertebrates. Here invertebrates means butterfly do not have backbone. Butterfly belongs to the phylum Arthropoda. It is found everywhere in the earth except oceans and very cold places. We can see butterfly in open sunny environment in garden, flower fields, forest, bank of stream, meadows, etc. You may have observed the butterfly flying around your fields, in your gardens, in your houses with different colors and structures. We know, like other insects, butterfly also has hard outer covering called exoskeleton. It supports and protects the body of butterfly. The body of butterfly has 3 main parts. They are head, thorax and abdomen. The body of butterfly has 3 main parts. They are head, thorax and abdomen. 3 pairs of jointed legs and 2 pairs of large scale covered colorful wings are present on its thorax. Its mouth parts have a long tubular pipe called proboscis. You know what do you mean by proboscis? Proboscis is a part in the head of butterfly which helps butterfly to suck the nectar. Nectar means juice of flower. Butterfly has a pair of antennae and a pair of compound eyes on its head. This antenna present in the butterfly helps in providing the sense of smell. You know, different kinds of butterflies have different colors and patterns in their wings. These colors and patterns are used to distinguish male and female butterflies. During breeding season, male and female butterflies come to each other for mating. While mating, male releases sperms in the female reproductive tract. After mating, female butterfly releases eggs. You can also catch a butterfly using a net. You can observe its body parts and draw a well-labeled diagram of the body of a butterfly. You can observe the head, observe the thorax, and observe its abdomen. See its wings, its colors. You can catch two or more than two types of butterflies and observe. The structure may be different. The colors of the wings will be different. But what the common you'll find in them is the total body of every butterfly or most of the butterfly will be divided into head, thorax and abdomen, and they all have wings, as well as they have 3 pairs of jointed legs and 2 pair of large scale covered colorful wings that are present in their thorax. Okay, now after that let's learn about the life cycle of a butterfly. Do you know what the life cycle is? Life cycle is a series of changes that an organism undergoes from its beginning to its sexual maturity. What is life cycle, students? Life cycle is a series of changes that an organism undergoes from its beginning to its sexual maturity. You can observe yourself. You were very small when you were born. Now you are getting older day by day. After some time, you will be converted into teenagers, adult, and you will be old. Here, in the same way, the butterfly also takes birth with the help of eggs, and they change their states. They become larva, they become pupa, and they become adult. Let's see about the life cycle of butterfly. The life cycle of a butterfly completes in different physical stages. The different physical stages are egg, larva, pupa, and adult. This is called metamorphosis. What is metamorphosis? The process in which life cycle completes in 4 different stages, that is egg, larva, pupa, and adult, is called metamorphosis. I repeat, the life cycle of butterfly completes in 4 different physical stages. They are egg, larva, pupa, and adult. First, let's know about the egg. Egg is the first stage in the life cycle of butterfly. Female butterfly lays egg on or underside of a leaf. Most of the butterflies lay egg singly, but some lay in cluster. The eggs attach to the leaf by glue-like substance secreted by the female along with the eggs. The shape of the eggs may be oval, spherical, or round. They may be white, green, or yellow in color. Okay, what is egg? Egg is the first stage in the life cycle of butterfly. Where does the female butterfly lays eggs? Female butterfly lays eggs on or underside of a leaf. And what is the shape of the eggs? The shape of the eggs may be oval, spherical, or round. And you know what is the color of the egg? The color of the egg may be white, they may be green, or they may be yellow in color. Now, larva. After 2 days, the eggs are laid by the female butterflies, maybe 2 or 3 days, or it may be even a month. Eggs hatch out into larva. During suitable environment, an egg hatches into a larva, which we call as the caterpillar. This larva we call it as a caterpillar. It is the second stage in the life cycle of a butterfly. A caterpillar has cylindrical body with a mouth for chewing. The body of larva is covered by small hairs. It has small legs called seta. Larvae are voracious eaters and they grow rapidly. Just after hatching, it starts eating remaining of the eggshell. After that, it starts eating the leaves, buds or flowers of the plant where they laid. A larva can shed its skin 4 to 5 times. It is called molting. What is molting? The process of shedding of skin is called molting. When a caterpillar reaches its full size, it stops eating and moving. It secretes silk-like substance from its mouth parts and attaches itself to a strong support. It starts to shed its skin to become pupa. Before becoming a pupa, a caterpillar surrounds itself by the silk to make cocoon. A caterpillar takes from 2 weeks to a month to convert into a pupa. Here, cocoon or puparium is a hard and dry outer covering. Inside the cocoon, a pupa grows. Here, what you need to understand is, after the female butterfly lays eggs on or underside of the leaf, after 2 to 3 days or maybe even a month, the larva hatches out of the egg. And the larva which hatches out of the egg after 2 to 3 days or even a month, they are called caterpillar. It is the second stage of the life cycle of butterfly. The larvae are voracious eaters. It means they only eat within their lifetime. लार्वा ले चाहिँ जुन क्याटरपिलर छ बटरफ्लाईको त्यसले चाहिँ अन्डाबाट निक्ले पछाडी खाली खाने काम मात्रै गर्छ का कतिन्जेलसम्म खान्छ त भन्दाखेरि almost it takes 2 weeks to a month. Now after that, त्यसपछि जब क्याटरपिलरले लार्वा अफ बटरफ्लाईले खान छोड्छ यसले चाहिँ के गर्छ त भन्दाखेरि आफ्नो वरिपरि एउटा कोकुन बनाउँछ. Now the larva inside the cocoon converts into pupa. Let's see what is pupa. Pupa is the third stage in the life cycle of the butterfly. Cocoon protects pupa from predators and drying out. Pupa neither eats nor moves. The tissues and organs of the pupa break down into soupy liquids. After that, it reassembles like an adult butterfly. This stage of butterfly can last from a week to several years depending upon the type of butterfly and the environment. Now, after a week or several years, many years, the pupa converts into adult butterfly. This adult stage is the fourth and final stage in the life cycle of the butterfly. An adult butterfly emerges out from the puparium. After that, it takes rest until it dries and hardens. This adult butterfly then flies for feeding and mating. Most of the adult butterflies live for about 1 to 2 weeks. And again, life cycle of the butterfly starts from egg and passes to larva, then passes to pupa, and finally ends to an adult. In this way, the life cycle of the butterfly completes. Thus, the cyclic process of a butterfly from an egg to the formation of an adult is called the life cycle of butterfly. Butterfly shows 4 different stages in its life cycle, which is called metamorphosis. Okay. Now, let's revise some important terms. What is life cycle? Life cycle is a series of changes that an organism undergoes from its beginning to its sexual maturity. Once again, listen carefully. Life cycle is a series of changes that an organism undergoes from its beginning to its sexual maturity. What is life cycle of the butterfly? The cyclic process of a butterfly from an egg to the formation of an adult is called the life cycle of the butterfly. I repeat, the cyclic process of a butterfly from an egg to the formation of an adult is called the life cycle of the butterfly. Now, what is metamorphosis? What is metamorphosis? The process in which life cycle completes in 4 different stages, that is egg, larva, pupa and adult is called metamorphosis. What are the 4 different stages of life cycle of butterfly? The 4 different stages of life cycle of butterfly are egg, larva, pupa and adult. Once again, what are the 4 different stages of life cycle of the butterfly? The 4 different stages of life cycle of the butterfly are egg, larva, pupa and adult. Egg. What is egg? Egg is the first stage in the life cycle of a butterfly. Number 2, larva. Larva is the second stage in the life cycle of the butterfly. What is larva also called? Larva is also called caterpillar. What is pupa? Pupa is the third stage in the life cycle of a butterfly. I repeat, pupa is the third stage in the life cycle of a butterfly. Next, adult. What is adult? Adult is the fourth and the final stage in the life cycle of a butterfly. Next, molting. What is molting? M-O-U-L-T-I-N-G, molting. The process of shedding of skin is called molting. I repeat, the process of shedding of skin is called molting. Next, cocoon. What is cocoon? Cocoon is a hard and dry outer covering of the third stage in the life cycle of butterfly. What grows inside a cocoon? A pupa grows inside the cocoon. Now, let me explain the life cycle of butterfly once again. There are total 4 stages of life cycle of the butterfly: egg, larva, pupa and adult. After the mating of male and female butterflies lays eggs on or underside of a leaf. After 2 to 3 days or maybe even a month, eggs hatches out to larva. The larva is also called caterpillar. The larva is a voracious eater. It means the larva eats within its whole time period. And from 2 weeks to a month, the larva converts into pupa. Larva after 2 weeks or after a month, depending upon the type of butterfly and the environment, conditions of the environment, larva converts into pupa. The pupa stage of butterfly can last from a week to several years depending upon the type of butterfly and the environment. After that, the pupa converts into adult butterfly. The adult butterflies live for about 1 to 2 weeks. If you have any confusions regarding this lesson, you can call or comment in the Facebook page of Radio Sathi. And that's all for today. Stay home, stay safe.
भाइ बहिनीहरूलाई फेरि स्वागत छ कार्यक्रम रेडियो स्कुलमा। तपाईहरूले भर्खरै कक्षा 5 र 6 का लागि तयार पारिएको कक्षा सुनिसक्नु भएको छ। कक्षा सुनिसकेपछि तपाईका केही प्रश्न वा जिज्ञासा भएमा रेडियो साथीको फोन नम्बर 023 563 037 मा फोन गरेर प्रश्न टिपाउन सक्नुहुनेछ वा हाम्रो फेसबुक पेजमा समेत प्रश्नहरू पठाउन सक्नुहुनेछ। अर्को कक्षामा भाइ बहिनीहरूको जिज्ञासाको समाधान गर्ने प्रयास गरिनेछ। अबको पालोमा कक्षा 7 र 8 का भाइ बहिनीहरूका लागि तयार पारिएको कक्षाहरू सञ्चालन गर्दै कक्षा 7 र 8 का विद्यार्थी भाइ बहिनीहरू कापी कलम लिएर तयार रहनुहोस् है त।
Namaste and welcome to you all in this radio program conducted by Radio Sathi 98.6 MHz. Okay, today again I want to welcome to you all again in our class of science related to class 7 and 8, and in our previous class we have learned about the many things about scalar quantities, vector quantities, what kind of quantity is known as scalar quantity and what kind of quantity is known as vector quantity, and after that we have known about distance and displacement. After that we have known about speed and velocity, and again after that we have done some difference between speed and velocity. After that we have tried some numerical. I have left some work for you to do. Okay, and I think now it is time to check your work, and I would like to check your work, and I left the work as identify whether a given statement is scalar or a vector. Okay, we should identify whether the given quantity is scalar or a vector. The mass of a substance is 5 kg. I have given you the first question as the mass of a substance is 5 kg. The value is given to you 5 kg, but no direction is given, so it is a scalar quantity. After that, the temperature of a room is 26 degree centigrade, okay, or the temperature of a room is 26 degrees Celsius. Then it also do not have any direction, so we can call it also as a scalar quantity. After that, the force applied by a person is 500 Newton. The force applied by a person is 500 Newton. That means force, for applying any kind of force, there should be direction. Suppose force is applied in upward direction or downward direction, or either east or west or north or south. In any kind of direction force should be applied. So this force contain a direction, so this statement is a vector, okay. We should consider it as a vector quantity. And one numerical also I have left for you. If a car moves through a distance of 500 meter in 50 seconds, then calculate the speed of a car. Then you have a formula for speed. Speed equals to distance covered by time taken. Distance is given to you 500 meter, time is given to you 50 seconds. Then the speed of car is known as distance by time, that is 500 by 50 equals to 10 meter per second, okay. Speed is 10 meter per second. Now in our today's class we are going to learn about many more. We are going to learn about uniform velocity, non-uniform velocity, average velocity, acceleration and retardation, and after that we will see some kind of work. I hope this many work can be completed in our today's class. Let's see how much we can. If we could not complete this work, then it will be left for the upcoming classes, okay. Now I will like to take you once to the scalar quantity and vector quantity, because this concept is really very much necessary for you all to know. Scalar quantity are those quantity which have only magnitude, which don't have any kind of direction. Suppose I already give one example by asking you question. The mass of a block is 5 kg. That means 5 kg is neither towards east nor towards west nor up nor down. Any kind of direction is not there, so it is a scalar quantity. Let's set up that in our mind, okay. Scalar quantity means only value, that means no direction, then we call it as a scalar quantity. Mass, length, time, density, distance are known as scalar quantity. And vector quantity means those quantity which have both magnitude and direction is known as vector quantity, okay. Such as force, I already give one example. Force, displacement, velocity have a direction, so that is called a vector quantity. And last time we have seen about speed and velocity. We have defined speed as the speed of a body can be defined as the distance traveled by a body per unit time. Speed formula is distance traveled per unit time, and displacement, for the displacement we have calculated velocity. Velocity equals to displacement covered per unit time. Please do not be confused in this matter, because speed equals to distance by time, velocity equals to displacement by time. Distance is a scalar quantity, displacement is a vector quantity, because in displacement we need direction, so for velocity direction is needed, for speed direction is not needed. We can say by that way, okay. Now the unit for speed is also meter per second and unit for velocity is also meter per second. Then how can we differentiate between the unit of speed and velocity? There is no any kind of differences, but we know the differences by taking a direction in velocity. Suppose a car is moving 5 meter per second in a velocity of 5 meter per second. If we say like this, then we should say a direction towards east or towards west. But if I take speed, suppose a car is covering a distance of, I am using here the word distance, okay, don't be confused. Car is covering a distance of 5 meter in 1 second, then the speed of car is 5 meter per second. Then in this case, this is the speed of car and we do not care about the direction, okay. As to talk about the today's class, we will discuss about uniform velocity or a constant velocity, okay. What do you mean by uniform velocity or a constant velocity? But we know about velocity. Now there are new term for you, uniform velocity and a constant velocity. let us define this at first. An object is said to be in uniform velocity. Please write on. An object is said to be in uniform velocity if it covers equal displacement in equal interval of time. If it covers equal displacement in equal interval of time. For example, a car moving in a velocity of 10 meter per second in every time interval. A car moving in a velocity of 10 meter per second in every time interval. Now what does it mean is, if any object, we have taken here one example of car which is moving a distance of 10 meter in every 1 second. Suppose in first second it have occupied a distance of 10 meter, and in next second also it have occupied a distance of 10 meter. Okay, we call displacement because we are reading about velocity. Okay, don't be confused. Displacement of 10 meter and again the displacement of 10 meter. By that way, in each and every second, let us imagine a car. Okay, in each and every second it is traveling a distance of 10 meter. That means now the velocity of a car is constant, that is 10 meter per second for first second also, and for the next second it is again 10 meter per second. That means the velocity is not increasing, neither increasing nor decreasing. That means the velocity is same throughout the motion of a car. Okay, so by this way we can say that car is in a uniform velocity, constant velocity. I hope you all are clear about it, about the uniform velocity. Okay, and now let us discuss about non-uniform velocity. What do you mean by non-uniform velocity? Let's write on the definition for a non-uniform velocity. An object is said to be in non-uniform velocity. An object is said to be in a non-uniform velocity if it covers unequal displacement in equal interval of time. Unequal displacement in equal interval of time. Okay, give a full stop. We can take any example. Suppose a car is moving in 10 meter for 1 second, and after that in next second the car is moving for 5 meter only. That means its velocity is reduced. Yes or no? At first velocity was 10, after that for next second the velocity was 5, and next second again the velocity will be 15 or 20, or either the car stops. That do not matter for this. Okay, so this kind of velocity is known as a non-uniform velocity. I hope you all are clear about it. Okay, now we will see about the differences between uniform velocity and non-uniform velocity. In uniform velocity, let us see in uniform velocity what happens is that any object covers equal displacement. Okay, in equal interval of time. Suppose in every second an object covers the distance which is equal. Suppose in every second for the uniform velocity object covers 10 meter, then in first second also 10 meter, second also 10 meter, in third upcoming second is also 10 meter. By that way we can know about the uniform velocity or constant velocity. After that, non-uniform velocity, or any velocity of a car is being fluctuating. That means in first second when the car starts from rest, or when a car starts from rest, its velocity was no any velocity, it was 0 because car was at rest. After that it gains a velocity of 10 meter per second. After that again 15 meter per second, 20 meter per second, 25 meter, 30 meter. The velocity is going on increasing. That means velocity is not uniform. This is non-uniform. Okay, so now I'll take you to the next thing to be discussed, that is called a average velocity. Now what do you mean by average velocity? Why this word came into existence? That means before average velocity we have discussed about non-uniform velocity. That means we cannot say at that case the velocity of car is 15 meter per second, because car velocity is being increased or either being decreased. Okay, in any case we cannot say the actual velocity. That means now how to define, how to get the exact amount of velocity for the non-uniform velocity. If you are asked a car is moving from rest to the motion and the velocity is non-uniform, then how you can calculate the velocity of such car? Then the new term will come for you, that is called average velocity. Okay, let us define this average velocity at first, and after that we know about the calculation of the average velocity from those those objects which are moving in non-uniform velocity. Okay, average velocity, let us define, students. It is defined as the ratio of total displacement covered to total time taken. It is defined as the ratio of total displacement covered to total time taken. Okay, average velocity equals to total displacement covered divided by total time taken. I repeat once, it is defined as the ratio of total displacement covered to total time taken. We have a formula right below one line. Okay, average velocity equals to total displacement covered divided by total time taken. That means by same way, if you take a displacement, then you have calculated average velocity. If you take a distance, then you will calculate average speed. That means the terms are similar, but there is a difference in the direction. One have direction, other do not have a direction. Okay, then if any vehicle do not have a constant velocity, that means the velocity of such vehicle is non-uniform. Okay, the velocity is non-uniform, then how we can calculate the average velocity? We cannot say exactly the velocity of this vehicle is 15 meter per second or 20 meter per second, because it is going on increasing or either going on decreasing in case of non-uniform velocity. Then one thing we know is total displacement covered by the vehicle, because we don't know at any point of instant of time the velocity of that vehicle, but we know how much distance displacement it have covered by starting from a one point initial point to the final point. Then we can calculate all the total displacement. Suppose a car have moved towards to the distance of 500 meter. Okay, in total it have occupied a distance of 500 meter, and the time taken, total time taken for the vehicle to reach the displacement of 500 meter is 50 seconds. That means now what is the average velocity of that vehicle? You will calculate by applying it on the formula which you have written before. Average velocity means total displacement by total time. Displacement is 500 meter and the total time taken is 50 seconds. Okay, that means you will get the velocity, that is 10 meter per second. Okay, in case of this we will get the average velocity by this way. Okay, I hope you are clear about it. Now let us discuss about acceleration. Okay, acceleration, let us discuss about the acceleration. Now it is defined as the, let us write the definition for acceleration. It is defined as the rate of change in velocity. It is defined as the rate of change in velocity. Okay, give a full stop, and after that its SI unit is meter per second square. Its SI unit is meter per second square. Then what do you mean by acceleration? If a vehicle have a constantly increasing velocity or constantly the change in velocity, then we can call such vehicle have a acceleration. Such vehicle have a acceleration. Imagine that sometime you will be seated on the motorbike. Then at first the velocity of motorbike is 10 meter per second. After that the driver or those who ride the motorbike have extended, changed the velocity up to 20 meter per second. After that 25 meter per second. After that 30. After that 35. It is constantly increasing per unit time. That means the rate of change in velocity is there. That is per unit time is there, because as the word comes their rate, then there will be per unit time. Then we can call the velocity is being increased or decreased. Let us say the change in velocity is there. That means per unit time, by how much the velocity is being changed. Try to understand, students. Per unit second, in per second, by how much the velocity is being changed. Such velocity, such change in velocity, we call it as acceleration when we divide it by the time interval. Okay, there are two causes for the acceleration, because there is change in velocity. There are two causes. Either there should be change in magnitude of velocity. I repeat once, either there should be change in magnitude of velocity, that means value of velocity, suppose 15 to 20, 20 to 25, by that way there should be change in velocity, or there should be change in the direction of a body, of a moving body. When the direction is changed, then the new velocity will be formed, because whenever the direction is changed, then we can say there is the change in velocity. Okay, now acceleration, let us write the formula for acceleration. Acceleration equals to change in velocity divided by time taken. Change in velocity divided by time taken. Okay, change in velocity. How to know about the change in velocity for the case of acceleration? Then we will write again equals to, give a equals to and write below final velocity minus initial velocity divided by time taken. Okay, final velocity minus initial velocity divided by time taken. This is known as a change in velocity. Okay, this is known as a change in velocity. Final velocity minus initial velocity, if we do that, then there is a difference in velocity, that is the change in velocity. Whenever we divide change in velocity, that is meter per second. Whenever again it will be divided by second, then it will be meter per second square. Don't be confused. The unit is discovered by this way, my dear students. And I hope you all are clear about uniform velocity, non-uniform velocity, average velocity and acceleration. Till now we have learned this thing. Now we will see about the next thing, that is called a retardation. Okay, negative acceleration is known as a retardation. Negative acceleration is known as a retardation. Please write on. Negative acceleration is known as the retardation. Okay, now what do you mean by negative acceleration and what do you mean by positive acceleration? Positive acceleration is simply acceleration, but negative acceleration is known as a retardation. Okay, now in what case there will be positive and what case there will be negative? Because we have formula for acceleration is v minus u by t, that is final velocity minus initial velocity divided by time taken. Suppose, let us take one example. If a car is moving from rest, that means the velocity is 0, starting velocity, that is initial velocity u will be 0. Okay, and the final velocity, the now car have been started and there is fluctuation in velocity. Okay, there is change in velocity, and now the final velocity of the car is 50 meter per second. That means initially it was in rest, that is 0 meter per second. After that it have a velocity of 50 meter per second. That means till then there is a change in velocity, that means there is acceleration. Now what is the acceleration of that vehicle? Then we can subtract v minus u, that means v means 50, that is final velocity, minus u means initial velocity, that is 0. 50 minus 0, and the total time taken. In how much time the velocity have acquired, the vehicle have acquired the velocity 50 meter per second. That means let us take a time to be 10 second. Okay, that means the change in velocity is 50 minus 0, that is 50, divided by 10. 50 by 10 is 10 5s are 50, that is your answer will be 5. 5 meter per second square is the change in acceleration. But in same case, if the velocity of a vehicle is 50 meter per second at first, if you are given one question, the velocity of a vehicle is 50 meter per second, then after that at last the velocity of the vehicle, that is the vehicle came into rest, then what is the actual acceleration of that vehicle? Then how do you find it? Because in this case initial velocity is given as 50 meter per second and final velocity is given as 0 meter per second, but in our formula there is given v minus u by t, but we will take final at first, that means 0 minus 50 by t. 0 minus 50 means, let us take same time 10. Okay, 10 second. Okay, 0 minus 50 by 10, that is minus 50 by 10. It looks a little bit different. Minus 50 by 10, negative sign is introduced over here. Minus 50 by 10, that is equal to minus 5. Now where by how did we get that sign minus? Because in this case we have already defined retardation as a negative acceleration. Now we can say that now the vehicle is not in acceleration, now the vehicle is in the point of retardation. Okay, we can know about that thing by this way, because let us take one example. If a vehicle is increasing velocity, if a vehicle have an increasing velocity, then obviously there will be a acceleration. Okay, keep this thing properly in your mind. If a vehicle have an increasing velocity, then obviously there will be a acceleration. But if a vehicle do not have an increasing velocity, but if it have a decrease in its velocity, then obviously there will be a retardation, because on the basis of decreasing, the final velocity will be less than the initial velocity. Okay. I hope you all are clear about our today's class. Okay, once I will revise everything that we have read today about uniform velocity. Uniform velocity भनेको कुनै पनि एउटा vehicle, कुनै पनि एउटा vehicle यदि straight line मा हिँडिरहेको छ भने उसले पार गर्ने दूरी चाहिँ प्रत्येक सेकेन्डमा बराबर दूरी पार गर्छ. सपोज डिस्टेन्स पार गर्छ, डिस्प्लेसमेन्ट. Okay, in case of velocity we will take displacement. Don't be confused, because displacement is related to velocity, and for speed we will take a distance, and both are same, but displacement have direction, speed do not have a direction. Be clear about this. Okay, that means any vehicle, कुनै पनि vehicle ले एउटा फिक्स्ड डिस्प्लेसमेन्ट कभर गर्छ फिक्स्ड इन्टरभल अफ टाइममा भने हामी त्यस्तो velocity-लाई युनिफर्म velocity भन्छौं. Check the definition once again. Okay, we are revising our today's class. I hope you all are clear about that. I have given you one example. मैले एउटा example पनि दिएको थिएँ. एउटा कारले यदि 10 meter per second every second मा 10 meter distance पार गर्छ भने त्यो कारको velocity कति हो? युनिफर्म छ, त velocity constant छ, त्यो velocity चाहिँ 10 meter per second हो. एभ्री टाइम इन्टरभलमा प्रत्येक सेकेन्डमा कार कुद्ने डिस्प्लेसमेन्ट चाहिँ 10 मिटर हुन्छ भन्ने कुरा हामी जान्दछौं. अनि अर्को कुरा चाहिँ नन युनिफर्म भेलोसिटी. नन युनिफर्म भेलोसिटी भनेको अब त्यही कारले प्रत्येक सेकेन्ड 10 मिटर कुद्दै गरेको कारले अब 15 मिटर कुद्न थाल्यो. प्रत्येक सेकेन्ड एउटा सेकेन्डमा 15 मिटर, अर्को सेकेन्डमा 20 मिटर कुद्न थाल्यो भने अब भेलोसिटी त सेम भएन, भेलोसिटी त कन्स्टेन्ट भएन. अब भेलोसिटी कस्तो भयो? नन युनिफर्म भेलोसिटी भयो. Okay, we will define non-uniform velocity by this way also for our better understanding. Okay, average velocity. About the average velocity. अब average velocity चाहिँ हामी कसरी फाइन्ड गर्छौं? यदि कुनै पनि कारमा velocity non uniform छ भने अब हामीलाई कुनै पोइन्टमा त्यो कारको velocity कति हो त भन्दाखेरि अब हामी त्यो कारको एभरेज velocity क्याल्कुलेट गर्छौं. एभरेज velocity भनेको कसरी क्याल्कुलेट गर्छौं त? अब कारले कति डिस्प्लेसमेन्ट कुद्यो सुरुदेखि लास्टसम्म, बिकज अब बीचमा त त्यसको velocity मा चेन्जेस आइरहेको थियो. अब सुरुदेखि अन्तिमसम्मको डिस्प्लेसमेन्ट हामी लिन्छौं अनि त्यसलाई सुरुदेखि अन्त्यसम्मको डिस्प्लेसमेन्ट पार गर्न लाग्ने समय लिन्छौं हामी, अनि त्यसलाई हामी डिस्प्लेसमेन्टलाई टाइमले डिभाइड गर्छौं र हाम्रो भेलोसिटी भनेको एभरेज भेलोसिटी हो. ओके, लेट अस डिफाइन क्लियरली अबाउट दिस एभरेज भेलोसिटी. अब यति भनिसकेपछि केही कन्फ्युजन हुनु हुँदैन, because whenever you feel confusion, just turn over the page of your book and try to get some ideas from your book, and try to get your ideas from the definition which we have written right now. Okay, by this definition also you will, for your better understanding, you will know further more thing. Okay, and after the completion of this class, I request you to go through this definition once again, because revision is quite necessary for the student for their better learning. Okay, जुन स्टुडेन्टले रिभाइज गरिरक्छ पढेको कुरालाई उसलाई छिटो भन्दा छिटो आउने गर्दछ, र जुन स्टुडेन्टले अब लेखेको कुरा पढेको कुरा एकचोटी सारिसकेर भयो. Okay, if they copy once, if they read once, then they feel that it's over, then the student will not get clear points which I mean, okay, which the teacher mean from the class, okay, which the teacher gives, then the point cannot be taken by the student, because our brain may forget this kind of things. Okay, so revision is quite necessary for us. Okay, acceleration. As to give some idea about acceleration in Nepali, okay, कुनै पनि भेहिकल को भेलोसिटी चेन्ज भइरहेछ भने अब चेन्ज हुँदै गरेको भेलोसिटीमा के हुने रहेछ त? एक्सेलरेसन हुने रहेछ. यदि चेन्ज हुने भेलोसिटी इन्क्रिज हुँदैछ, भेलोसिटी बढ्दैछ र चेन्ज हुँदैछ, 5 बाट 10, 10 बाट 15 पर सेकेन्डमा भेलोसिटी चेन्ज हुँदैछ भने त्यहाँ एक्सेलरेसन हुन्छ, किनभने चेन्ज इन भेलोसिटी पर युनिट टाइम इज द फर्मुला फर एक्सेलरेसन. ओके, आई होप यु अल आर क्लियर अबाउट दिस. But when the velocity is decreasing, there is the point called retardation. Okay. Now there is something to remember, points to remember, important points. Okay. If a body moves with uniform velocity, okay, we have talked already about uniform velocity. If a body moves with uniform velocity, then at that case acceleration will be 0. Okay, be careful, because there is no change in acceleration, acceleration will be 0. Okay. If a body starts from rest, okay, if a body means if any vehicle starts from rest, कुनै पनि भेहिकल रेस्टबाट सुरु हुँदैछ भने, रेस्टबाट कुद्न सुरु हुँदैछ भने त्यसको स्टार्टिङ भेलोसिटी, इनिशियल भेलोसिटी जसको भ्यालु चाहिँ u हो, त्यसको भेलोसिटी कति हुन्छ? 0. इनिशियल भेलोसिटी चाहिँ 0 हुन्छ. By that way, if a body comes to rest, if any vehicles comes to rest, then the final velocity will be 0. V will be 0. If starting from rest, then u will be 0. If coming into rest, then v will be 0. Okay. Now, if a body falls freely under gravity, एउटा कुनै पनि अब्जेक्टलाई हामी फ्रीली झार्दिन्छौँ अर्थको सर्फेसमा भने ग्रेभिटेशनल फोर्स which we have already learned that pulls each and every object towards the earth, then there is acceleration because now the speed of that the velocity of that object is being increased. Okay, speed र velocity भनेको उस्तै कुरा हो, तर velocity मा चाहिँ direction हुन्छ, speed मा direction हुँदैन. Okay, let's not be confused about this thing, my dear students. Okay, if a body is projected upward, त्यसै गरी कुनै पनि बडीलाई हामीले माथि प्रोजेक्ट गर्यौं, माथि फ्याल्दियौं एउटा ढुङ्गालाई भने त्यो ढुङ्गाको भेलोसिटी के हुन्छ? माथि डाइरेक्सन त माथि जाँदैछ, त्यही भएर हामी भेलोसिटीको कुरा गर्न सक्छौं. ढुङ्गासँग भेलोसिटी छ, द स्टोन हैव अ भेलोसिटी, देन slowly the velocity of that stone will be decreased, then we can say there is retardation. Okay, because there is decrease in velocity, velocity कम्ती हुँदैछ, त्यही भएर त्यो स्टोनको के हुँदैछ? रिटार्डेसन हुँदैछ स्टोनमा. Okay, then at that case we can say the acceleration is equal to minus 9.8 meter per second square. अब अर्थले तान्ने एक्सेलरेसन चाहिँ 9.8 हो, जुन चाहिँ अब if a body falls freely under, कुनै पनि बडी मुनि झर्दैछ भने त्यसको एक्सेलरेसन चाहिँ 9.8 meter per second हुन्छ. Okay, this is the acceleration due to gravity of the earth. And if a body is projected upward, फेरि त्यही एटमोस्फियरमा त्यही अर्थमा कुनै पनि अब्जेक्टलाई हामी माथि फ्याल्दैछौँ भने त्यो अब्जेक्ट के हुन्छ? माथि माथि जाँदा जाँदै त्यसको भेलोसिटी लो हुन थाल्छ र एउटा स्टेजमा गएपछि त्यो भेलोसिटी के हुन्छ? 0 हुन्छ र त्यो अब्जेक्ट फेरि केमा पुग्छ? रेस्टमा पुग्छ अनि फेरि इन्क्रिज हुन कन्डिसन हुन्छ. तर माथि जाँदा के भयो त? भेलोसिटी डिक्रिज भयो, त्यही भएर एक्सेलरेसनको भ्यालु चाहिँ नेगेटिभ भयो, यहाँनिर रिटार्डेसन भयो. द्याट इज 9.8 meter per second square. I hope our today's class is fruitful for you all, and by saying this much, I would like to conclude my today's class by giving some assignment to do at your home. Okay, let us write some questions for your practice. Okay, this time I am here with the numericals. Okay, first one, calculate the average velocity of a motorbike. Calculate the average velocity of a motorbike if it covers distance of 500 meter in 20 seconds. If it covers a displacement velocity means if it covers a displacement of 500 meter in 20 seconds. Okay. After that, what is the acceleration produced on a body? What is the acceleration produced on a body moving with uniform velocity of 15 meter per second square? Moving with uniform velocity of 15 meter per second square. This is our next question. Now, one more question to you all. If a velocity of a car increases from 5 meter per second to 10 meter per second, then calculate its acceleration. Calculate its acceleration. Okay, we have formula for acceleration, we have formula for average velocity, that is total displacement by total time taken. Okay, that is information is given to you. Your work is just to apply it in formula and get your answer. Just to apply in formula, get your answer. Okay, I hope that today's class is beneficial to you all, because the class through radio program, if you give more attention, then more beneficial. think that if you give more attention, then the class will be more beneficial. If less attention, then the class will go on and you will lag behind for that. Okay, so I request you all to give your maximum attention for this class for half an hour. For half an hour, class 7 and 8 students will give their maximum attention so that you can grab each and everything which is presented by this radio program. Okay, by saying this much, me myself, Krishna Prasad Pokhrel from Mechinagar 6 will ask leave from you all in next week again with the new chapter, with the new topic, and stay safe, stay healthy at your home, and be aware about this COVID-19 and try to make your family member aware, and but not be fear of these diseases. Okay, because if we be aware, then we are going to win these diseases. Okay, let's be positive and let's read harder from our side, although the schools are being closed in these days. Okay, thank you very much.
भाइ बहिनीहरू, तपाईहरु अहिले कार्यक्रम रेडियो स्कुल सुन्दै हुनुहुन्छ। कक्षा सुनिसकेपछि तपाईका केही प्रश्न वा जिज्ञासा भएमा रेडियो साथीको फोन नम्बर 023-563-037 मा फोन गरेर प्रश्न टिपाउन सक्नुहुनेछ वा हाम्रो फेसबुक पेजमा समेत प्रश्नहरू पठाउन सक्नुहुनेछ। अर्को कक्षामा भाइ बहिनीहरूको जिज्ञासाको समाधान गर्ने प्रयास गरिनेछ। अब आजको अन्तिम कक्षामा कक्षा 9 र 10 का विद्यार्थी भाइ बहिनीहरूका लागि कक्षा सञ्चालन हुँदैछ। कक्षा 9 र 10 का विद्यार्थी भाइ बहिनीहरू कापी कलम लिएर तयार रहनुहोस्।
Hello everyone, a very good morning to all of you. It's another Wednesday and I am your radio tutor Ishwar Ghimire is back from Mechinagar 9 for English medium science class. Students, we are having a bit tough time for some interval nowadays. So we are having a radio class through Radio Sathi 98.6 MHz. We are trying to help you learn some topics although you are at home. For today, I'm going to have a class for class 10 and today's topic is chapter heat. First of all, what comes in your mind, students, when you discuss about heat? Obviously, it's very common concept to you. In lower class also, you have learned about chapter heat. Simply, heat is a form of energy that gives sensation of warmth. Yes, it gives sensation of warmth to us. It is simple definition to us. But if we go for molecular theory tells that heat is the total kinetic energy of molecules of a system. Yes, if there are certain number of molecules in a vessel, then if you want to find out heat of the total molecules of the vessels, then you have to add heat of each and every molecules. If you add all the heat present there, then the total will be the heat of the vessel or the molecules of the vessel. Yes, simply we know about simple concept, that is when a hot body is kept in contact with a cold body, it is transferred from hot body to cold body. Yes, always it transfers from hot body to cold body without any mechanical work. All other forms of energy are converted into other energy that increases the disorder of the system. Yes, all other forms of energy are converted into heat energy that increases the disorder. Disorder simply means entropy. It is new concept to you. We are not going to discuss in detail about entropy for now. Yes, simply disorder of the system will increase and that will result into increase in heat. Simply learning heat, we need to know the unit of heat also. It is not new to you. Simply you know unit of heat is joule. Yes, in SI system heat is measured in joule. And in CGS system, you may know about it also. Yes, in CGS system, heat is measured in calorie. Yes. So sometimes in SCE, you will be asked a question about what do you mean by 1 calorie. If it is asked to you, then how do you reply? To reply, you can simply say like this. 1 calorie heat is defined as the amount of heat required to raise the temperature. Yes, amount of heat required to raise the temperature of 1 gram of pure water through 1 degree centigrade. Yes, of 1 gram of pure water through 1 degree centigrade. Yes, if you supply certain amount of heat and you are able to increase the temperature of 1 gram of water by 1 degree centigrade, or you also can say by 1 Kelvin, then that it is 1 calorie heat. Yes, if you are asked about relationship between joule and calorie, then you may know about it already. It is very simple. Yes, 1 calorie is equal to 4.2 joule. Yes, 1 calorie is equal to 4.2 joule. Learning the chapter heat, we also have to discuss about temperature. Very common definition about temperature is very common to you, very familiar to you. That is, temperature is the measure of degree of hotness or coldness of a body. You know about this already. But here in class 10, we define the temperature in molecular theory. In this, we have to define temperature in that way. Temperature is defined as the average kinetic energy of molecules of a system. Yes, temperature is defined as the average kinetic energy of molecules of a system. Yes, students. And it is measured with a thermometer. Yes, temperature is measured by thermometer. And what was for heat, students? I didn't mention before. Heat is measured by calorimeter. Yes, calorimeter. Device for measuring it is calorimeter, and the device for measuring temperature is thermometer. And you know the SI unit of temperature? Yes, that is Kelvin, not new to you. Kelvin is the SI unit of temperature. The most commonly used unit of temperature is what? Yes, degree Celsius, or simply degree centigrade. You can say like this. There are other units of temperature also. These are simply Fahrenheit, that is degree Fahrenheit. Another new one also is there, that is Reaumur scale, that is represented by capital R. We should not learn more about Reaumur scale for now. Simply you need to know there are some units of temperature. These are Kelvin, degree centigrade, and degree Fahrenheit. If you know this much, then it will work for you now for this level. Now we have to discuss about the topic absolute zero. What is absolute zero temperature, students? The lowest possible temperature in the universe, you can say. Yes, or simply the lowest possible temperature that can exist in this universe. It means kinetic energy of molecules of a substance becomes zero. It's called absolute zero temperature. Or simply, the lowest possible temperature in this universe is called absolute zero temperature. Absolute is there. Kelvin scale is absolute scale. So it is absolute zero here. That means absolute zero is 0 Kelvin temperature. What is it? 0 Kelvin temperature is absolute zero temperature. In degree centigrade, if you say, it will be around minus 273 degrees centigrade. Yes, minus 273 degrees centigrade. If in the universe anywhere, if you maintain the temperature minus 273 degrees centigrade, then nothing will be in motion, students. Everything comes at rest. So absolute zero we can define in this way also. The temperature where everything comes at rest is called absolute zero temperature. Yeah, we can mention like this also, because at absolute zero temperature there will be no kinetic energy of anything in the universe. Everything comes at rest. It means Earth going around the sun, now it stops going around. Moon goes around the sun, Earth, but this also will stop. Means everything will stop. Even air will stop to flow. Air also will stop to blow. Then we can't imagine the life. So we should not have absolute zero. It is very dangerous for living life. Yes. If you see the relationship between heat and temperature, then obviously when you heat anything, then its temperature increases. Do you know how the temperature increases? Because when you heat anything, it produces vibration on the molecules of that body. And when vibration increases, that means average kinetic energy increasing. If average kinetic energy of the molecule is increasing, that means temperature is increasing. Yes. So on heating, we can see the increase in temperature. We can say that heat is the cause and temperature is the effect. Yes. And you know one thing, that is heat always flows from high temperature to low temperature. Yes. If somewhere there is 10 degrees centigrade water and you mix that water with 5 degrees centigrade water, then what happens there? Obviously on mixing, the heat from 10 degrees centigrade water will flow towards water at 5 degrees centigrade. Yes. We can understand this in that way also. Water always flows from higher place to lower place. Yes. You have not seen water flowing from lower altitude to higher altitude. Have you seen that? No, because it is not possible. Gravity always pulls it down. You can understand the flow of heat also in the same manner. Heat always flows from high temperature to low temperature, as water flows from higher place to lower place. Yes. Sometimes you may be puzzled with some questions like this. If you have got a boiled water in a kettle that is boiling fully, that is around 100 degrees centigrade is there, and there is water in river flowing. If you mix that very hot kettle water to the river water, then what happens, students? What will lose it and what will gain? Obviously, as the kettle water is with high temperature, it will lose heat to river water, which is at low temperature. Yes. But you may be asked like this also. If you have got a glass of water, boiled water, and a bowl of water in a bowl where there is around 20 liter of water is there. Okay, 20 liter of water in a bowl and around half liter water in another device. Then where is more heat? You may be asked like this. You may be confused. Temperature of that glass water is more and you may think heat is there more. But it is not the case. You have learned the definition of it already. Heat is the total sum of kinetic energy of the molecules. Yes, it is total sum of kinetic energy of the molecules. So, although temperature of glass water is more, means although temperature of average kinetic energy of the glass water is more, the number of molecules in glass is less. The number of molecules of water in glass is less, but the number of molecules in bowl water is more. So, if you add all the energy of bowl water and glass water, then you will find out the total heat of bowl water is more than glass water. Or you can simply understand by another very common example also, like where is heat more, in water flowing in river or in glass? Obviously, although temperature of river water is very low, there are many molecules. So if you add all the heat of the molecules, you will find out total heat in river will be more than in glass. Okay. If you perform one activity to see whether temperature in two cases will be rising in same way or not, like one example is there. You can take 50 gram and 100 gram of water in two different beakers up around the same size. Keep the bulb of thermometer in one beaker and another bulb in another beaker. I mean, put one thermometer in one beaker and put another thermometer in another beaker and start heating. Supply the heat to it. Where do you find the rising of temperature faster? Obviously, the beaker with less water will show the rise in temperature faster than the beaker with more water. Why is it so? Because as there are less number of molecules in one bulb, the average kinetic energy will be more in that one and temperature also will be more. Yes. You may be asked some questions, students, in exam like this. We feel cold in winter and hot in summer. Why? It is very common question. In fact, yeah, we do so. But there is reason, scientific reason. Why do we feel so? Cold in winter but hot in summer. Simple answer is that we always feel cold when we lose heat to the environment. And we always feel hot when we gain heat from the environment. That is your basic thing. Now, in winter, our body temperature, or you simply say our skin temperature, is more than the temperature of surrounding. So when our skin comes in touch with surrounding, we lose heat to the low temperature. I mean, we lose heat to the surrounding. On losing heat, we feel cold in winter. But in summer, our skin temperature is less than surrounding temperature. So when we come in touch with surrounding, we gain heat from the surrounding and we feel hot. That is the simple reason in summer. Yes. Another example, another question you can see, well water feels cool in summer but warm in winter. Why? Yes. tubewell water also you have experienced. Taking bath with the help of tubewell water in winter, it will be easier for you because it feels warmer to us. But the same tubewell water in summer season feels cold. That is very good to us. Why does it happen? Because in summer, the temperature of water is less than our skin temperature. Yes, temperature of tubewell water is less than our skin temperature. So we lose heat to the water and we feel cool. But in winter, the skin temperature of us is less and the water temperature is more. So when we touch the tubewell water, we gain heat from that water and we feel warm. That is the reason. Yes. You may be asked about difference between heat and temperature also. It won't be very tough for you now. Simply you can define heat and temperature. That will be one definition, like it is sum of kinetic energy of molecules. Temperature is average kinetic energy of molecules. That is one difference. Next, you can say heat increases with mass, but temperature is independent of mass because it is average. Yes. Another is it is cause of temperature, and temperature is effect of heat. One is cause, another is effect. Next, it is measured by calorimeter. Temperature is measured by thermometer. Very simple. Another is SI unit of heat is joule. SI unit of temperature is Kelvin. Okay. So we have to see some effects of heat now. Yes. Heat changes the temperature of body. You know that. It also changes the size of body. It changes the state of matter also. Like on heating, you see liquid converting into vapor. That solid ice converts into liquid. It means changing the state of body. It changes the solubility of solute also. Yes. Solubility you have learned in class 9. You may know about it. It also changes the rate of chemical reaction. Little bit you may have learned in class 9. In class 10 you will learn in detail about this. Okay, in chapter chemistry. So some expansion caused by it. If we see, there are three types of expansion we can discuss. First is expansion of solid, then expansion of liquid, and also expansion of gas. Obviously on heating, molecules will vibrate and it will increase the volume of the object. Increasing volume of object means expansion. There are three types of expansion we can see. Expansion of solid, expansion of liquid, and expansion of gas. Yes. In solid also we can see certain types of expansion, like the expansion of length, expansion of area, and expansion of volume. In detail we will learn in class 11 science, but for now some examples we can see, some applications we can see of the expansion of solid. You have observed somewhere like some gaps are left in railway track. Have you observed? If you have seen railway track, you can see somewhere there will be gap between the railway track. Why is it kept so? Because reason is simple. During summer season, due to excess heat, the railway track starts expanding. Yes, you know everything expansion heating and contraction cooling. So railway track also gets expanded during summer. But if there is no gap left between the tracks, yes, if there is no gap left, then there will be no space for that expanded part to go. There is expansion taking place, but if there is no gap, then where does that fit in? The expanded part goes where? There is no place. That's why the gap is left there already, so that when it expands, the expanded part fills in that gap and there will be no bending of the track and there will be no chance of accident. Otherwise, if there is no gap, due to expanded part, the railway track starts bending and there is chance of accident of train. So gap is required there. You have seen around like electric and telephone wires are loosely kept in summer. Why it is so? But it is very tight in winter. Yeah. During summer there is more heat. Due to more heat, the wires of telephone or electric wire will be expanded more. When it will expand, it will be slagging down. Yes. But in summer, there will be less temperature. So contraction of wire will take place and it will be a bit tight. Yes. Also, you may have experienced a glass tumbler, simply a thick glass, a glass with thick bottom, that is simply called glass tumbler. that may break when you pour into it the hot water or hot tea. What is the reason behind this? Because when you put hot tea into that glass tumbler, then as it is thick, the inner surface starts getting expanded. Yes, inner surface of the glass tumbler gets heat and it starts to expand. But outer surface is not expanding because it has not reached there. So only inner part starts expanding, outer part remains as it is. There is uneven expansion, not uniform expansion. Inner part started to expand, but outer part has not started. Means there is uneven expansion. Due to that, it will make crack and it will make fall down. The tea you are pouring into it may come down. Yes, it may happen like this. There is also the expansion of liquid and gas. Simply solid expansion, the least. Liquid expands a little bit more, and among all three matters, gas expands the most, because the reason is simple. In solid, molecules are tightly bounded, so it cannot expand well. In liquid, a bit loosely bounded, so it can expand a little bit more. And in gas, molecules are very loosely bound, so it expands the maximum. Yes. Now we have to go to another topic of it, that is amount of heat and specific heat capacity. Okay. Amount of heat. What is amount of heat? I already discussed something about it. Simply, amount of heat is the measure of total kinetic energy of the molecules present in a body. Yes. If there are many molecules present, total amount of heat also will be more. Yeah. But simply there are two factors we can discuss about amount of heat. Yeah. Amount of heat depends upon two factors. First is amount of heat is directly proportional to mass of the body. Yes. If mass is more, means if number of molecules are more, then heat also will be more there. And another is average kinetic energy. Yes. If temperature is more, then also heat will be more. Simply, heat H or Q you can say, okay, Q. Q is directly proportional to M, that is mass of the body, and Q is directly proportional to d theta, that is change in temperature you can say, or simply average kinetic energy. Yeah, Q is directly proportional to d theta. If you mix these two, then you can simply get H is directly proportional to m d theta. Yes, m d theta. To replace that proportional sign with equal sign, we need some constant, and that constant here is S, letter S. So simply Q equals to S m d theta, or we can simply say Q equals to ms d theta. What is that? Ms d theta. This is also called the equation of heat. What is this? Equation of heat. And S used here is a proportionality constant. It is proportionality constant, which is also called specific heat capacity of the body. Yes, it is also called specific heat capacity of the body. Yes. So how can we define specific heat capacity now? As you have got the heat equation, Q equals to ms d theta. It is easy to remember also, student. ms d theta, very easy to remember. M for Mahendra, S for Singh, d theta. Simply D means Dhoni, Mahendra Singh Dhoni. MSD, it helps you to remember. MSD, it is very common name to you, so you may remember like that. MSD, Mahendra Singh Dhoni. Yes, MSD theta you can say. That is it equation. Now to define specific capacity, from the equation you can get S equals to H upon m d theta. Yes. If you keep S on one side, then S equals to H upon m d theta. Yes. Then keep all the things 1 there. I mean all the parameters 1. Then what do you get? I mean if you keep mass 1 kg and d theta also 1 degree centigrade, then what do you get? Then you will get S equals to H upon 1 into 1. That is S equals to H. Yes, S equals to H. So now we can define specific heat capacity of a substance is defined as the amount of heat required. Yes, amount of heat required to raise the temperature of 1 kg of substance through 1 degree centigrade. Yes, to raise the temperature of 1 kg of substance through 1 degree centigrade or 1 Kelvin. Yes, Now telling about unit of specific capacity, what do you get here? From the equation you can make it very easily. Joule per kg per degree centigrade. Yes, joule per kg per degree centigrade or joule per kg per Kelvin. It will be same. Yeah, there are many substances but their specific capacity is different. Like for example, water has specific capacity 4200 joule per kg per degree centigrade. Ice has 2100 joule per kg per degree centigrade. Iron has 470 joule per kg per degree centigrade. Mercury has 138 joule per kg per degree centigrade. Means we are finding different specific capacity for different substances. Do you know the reason behind it, students? Why does this happen? The simple reason is the speed of vibration of molecules in one substance is very different than other substance during heating or cooling. Yes. When you supply certain heat to one substance, the molecules may vibrate in one speed, but if you supply same heat to the another substance, the molecules will vibrate with another speed. Means in one molecule, in one substance you can see molecules vibrating faster, in another you can see molecules not vibrating that faster. Means vibration is different in different molecule with the same heat also. If vibration is different, that means average kinetic energy also is different. Yes, means rise in temperature also is different. By the same heat, you can't raise the temperature equally in two different substance of same mass. Yes, 1 kg of water needs 4200 joule of heat to raise its temperature by 1 degree centigrade, but 1 kg ice needs only 2100 joule to raise the temperature by 1 degree centigrade. And mercury needs only 138 joule to raise the 1 kg of mercury by temperature 1 degree centigrade. So it will be different. It is all due to different molecular vibration. Yes. As I have just said about value of specific capacity for water, that is 4200 joule per kg per Kelvin. This has so many usefulness, application in our daily life, students. You have seen people using cold sponging with water during fever. Yes, cold sponging is done. That is simply wet cloth is used, that is wet with water. Why are we using that? Why water? Why not other liquids? Because water has highest specific heat capacity. Yes, it means simply when you use water, then water takes for 1 kg, okay, for example, let 1 kg water, 1 kg of water takes 4200 joule of heat from your body, and temperature of water goes only 1 degree up. Yes, although it is taking 4200 joule from your body, water is still cold. Just 1 degree temperature is raised up. Means still it can take more heat from your body. So water is very useful. It has high specific capacity. On getting more heat, it remains still cold. So we can use further. Means water can take more heat from our body. So it can make our body colder faster also. That's why we can say we have to use water for cold sponging. It is better option. You have seen we use hot water bag but not hot oil bag. Yes, why do we use hot water bag but not hot oil bag? Because water has high specific capacity. Yeah, for cooling purpose water is very good. I discussed about fever just before. But do you know, students, for heating purpose also water is the best. How the same substance can be better cooling agent and better heating agent? You may think like that. Yes, but it is simple to know. Because water has high specific capacity. Yeah. If it is to take heat from other, it can take more heat and still remain cold. So it is good cooling agent. But when you are to heat, for that also, water gives more heat to you and still not getting colder faster. Means it can provide more heat to you. Yeah. In hot water bag, we use water because water has high specific capacity and it can give more heat to us without appreciable decrease in temperature. Means water is still hot to give more heat to us, so it is better heating agent too. Okay, so finally we can come to another one topic, that is thermal capacity of a substance. Simply for definition of it, the thermal capacity of a heat is defined as the amount of heat required to raise the temperature of a body through 1 degree centigrade. Yes, amount of heat required to raise the temperature of a body. I am telling here a body. I am not telling 1 kg body. Yes. If certain substance is given to you and asked to increase its temperature by 1 degree centigrade, then how much heat should you supply to that? That is thermal capacity of that body. Body may be 1 kg, maybe 5 kg, maybe 10 kg, whatever may be the size of body, maybe half kg. The heat needed to raise its temperature by 1 degree centigrade is thermal capacity. But if the body is 1 kg, at that time it is required to raise the temperature by 1 degree centigrade is specific heat capacity. Yes. Then comes another topic, that is calorimetry. It is simple thing to us. You know, when we mix two substances of different temperature, then one will lose heat, another will gain, and finally they'll come to same temperature. Yes, at that point heat lost by hot body is always equal to heat gained by cold body. Yes, when you mix two substances of different temperature together, then one will lose heat, another will gain, and finally will come to the same temperature condition, that is thermal equilibrium position. Yes, thermally they are with same temperature. At that point we see heat lost is always equal to heat gained. The equation also, this is the equation also, or simply called principle of calorimetry. Yes, heat lost is always equal to heat gained. Yeah, in thermal equilibrium I just discussed, if two objects or two things are kept together, I mean these two things are different temperature, when we keep together, one will lose, another will gain heat, and finally will come to the same temperature point. That condition is thermal equilibrium. Yes. So I think students, we are running out of time for today. I think you got some knowledge about chapter heat. If you have got the book, then you can see in book and follow many things given there. You may have got some idea from today's class. If you have some more questions, you can send the questions to Radio Sathi and we will discuss about it. We will get it resolved. For today, stay safe, stay home. This is Ishur Gimire signing off. Thank you. Bye-bye.
भाइ बहिनीहरू, आजका लागि सबै कक्षाहरू सम्पन्न भइसकेका छन्। कक्षा सुनिसकेपछि तपाईका केही प्रश्न वा जिज्ञासा भएमा रेडियो साथीको फोन नम्बर 023-563-037 मा फोन गरेर प्रश्न टिपाउन सक्नुहुनेछ वा हाम्रो फेसबुक पेजमा समेत प्रश्नहरू पठाउन सक्नुहुनेछ। अर्को कक्षामा भाइ बहिनीहरूको जिज्ञासाको समाधान गर्ने प्रयास गरिनेछ। भाइ बहिनीहरू, आजलाई कार्यक्रम रेडियो स्कुल यति नै। तपाईहरू यी सबै कक्षाहरूको अडियो हाम्रो फेसबुक टाइमलाइनमा गएर दोहोर्याई सुनेर थप प्रश्न हुन सक्नुहुनेछ। भोलिको कक्षामा पुनः हाम्रो भेट हुनेछ। लकडाउनका बेला घरमै बसी कार्यक्रम सुनेर अभ्यास गर्दै पढ्दै गर्नुहोला है त। तबसम्मका लागि सबै विषय शिक्षकहरूको साथमा प्राविधिक साथी करिना पौडेलसँगै म जिआर धिताल पनि बिदा हुन्छु। नमस्कार।